nice clean one to upload to YouTube. Okay, hello everyone, and welcome to Handmade Hero, the show where we code a complete game from scratch, no libraries, no engine, so that we can see absolutely everything that happens from start to finish when a game is running our computer. This series is designed to teach you about every last thing that goes on. And we have done a pretty good job getting ourselves up and running. We basically have a little kind of like stand-in tile map that we created yesterday. And so we're kind of in the thick of it right now, trying to basically get some notion of what our game engine will have to do so that we can start building it. And one of the things that I talked about over the past couple of days was that you don't want to start building things like a game engine before you know what they have to do and know how you want them to do it. Always write the usage code first is my mantra. I say it all the time and I mean it. And basically what I mean is we don't want to write a game engine until we have a game. And I know that sounds a little paradoxical because you're like, how can you write a game without the game engine? And the answer is just use whatever the dumbest stand-in thing is that you can and get the structure worked out properly. So what we're basically doing is we're just drawing rectangles on the screen and we're pretending that those rectangles are going to be something beautiful later on. And the goal there is to basically make it so that we can spend some time up front without having to invest any time in developing the engine, essentially making something that works the way we want our game to work so that we can look at it and go, here is exactly how we want our engine to function. So that when we build the engine components that we actually need, we're not wasting a lot of time designing them wrong, then we build the game only to find out that they're clunky and hard to use in the context of the game that we wanted. So that's what we're in the middle of doing right now. We're going to continue that today. If you are following along at home and you have pre-ordered the source code on handmadehero.org using the handy-dandy pre-order button, then you should have gotten a link in your email. And that link has a download page where you can download a zip file which has every day's source included in it. And if you look, we are currently on day 29, so you will want to unzip day 28 source code, the previous day. That is what I am starting with now, and so if you unzip that and start with that source code, you'll be exactly where I am right now. So let's go ahead and get ourselves, oops, it's a bad typing day, I can already tell, got to move that keyboard out a little bit. Let's go ahead and take a look at where we were, just so we can refresh our memory a little bit. We, at the end of last stream, had just gotten a little rectangle moving around, and here is our sort of fanciful little tile map that we had created. You know what might be interesting too, I think just for the sake of what we've been doing, it might be nice to clear the gutter area to black. I don't know if you guys remember, but basically we're only filling in sort of a region that we're pretending is our screen. We don't actually do anything with the rest. So it might be interesting to clear that to black, just so we don't have confusion about where the screen ends. That's just something that I think might be interesting. And the other thing that might be interesting too is to center this a little so we can kind of see the gutter area as well. I don't know, just something to think about. I think maybe before I talk about it, it's just something I kind of want to do. So we can jump into the, again, the Win32 code that displays us makes that actually pretty easy for us to do. So it'd be pretty easy for us to make that happen. Basically, we've got a function that sort of displays our bitmap to the screen. It's this Win32 display buffer in window call, right? And when we do that, if we wanted to, we could make a Windows call that cleared the screen first. It's called patblit, you know. So we could just go ahead and call that. I'll show you the call that I'm talking about, patblit. Yeah. So basically, all it does is it says, all right, I want you to take this rectangle that I'm going to pass in, the left, basically the left and top. That's just a misnomer there. It should be Y top, but I guess, yeah, anyway. You pass in the left and the top and the width and the height. It goes ahead and does whatever this operation is that you tell it to do. And blackness is what we want there. We're just going to tell it to do blackness. And then Windows will just do that clear. So that way the rest of the part of the window that we're not drawing to basically is going to be, where is that window width, window height? Got it right here. The rest of the window that we're not drawing to will just be cleared with blackness so we're not confused. And the other thing is we'll just set an offset here. We'll just set a little offset that's basically offset X, and offset Y. We'll basically set those to be like 10 pixels in or something just to leave a little gutter there. So stretch di bits is the function that we were calling, stretch di bits, that we were calling to copy our bitmap to the screen. You can see that it's got an X and Y dest in there. So if I want to, I can go ahead and just set that offset X and offset Y in here, and then when I go ahead and compile that, we should get a nice, yeah, there we go. So you can see, I just wanted to clean that up so we can just kind of see what the actual display is. Seems like a good idea to me. And then we can go ahead and go from there. Okay. So what we did yesterday is we sort of made a little, our little yellow, whatever you want to call this here, our little yellow rectangle, and he kind of walks around. We were trying to verify as well, and I guess I'll double verify that just because we were mentioning it before. Verify that we are hitting 30 frames a second so that we know that nothing weird's going on. Pretty soon, hopefully, we'll get a chance to write some debug code that makes it easier for us to always keep an eye on all this stuff. Right now, we have these kind of crazy printfs that are going on here that we use to verify some things, and I'd like to get out of the business of that, but we're not quite there yet. Baby steps, one thing at a time. But basically, we verified that we were running at 30 frames a second, and we verified that we could do some simple stuff like move a guy around. And so now what I want to do is I want to just take go a little bit further and just say, let's get the basic thing working of, let's have this little yellow, our little yellow rectangle here, let's have him actually bump into stuff so that when he hits the edge of the tile map, right? Let's have him stop, right? So that he doesn't sort of collide with things. And then let's also go ahead and make something so that when he exits out through one of these doors, he actually goes to the next tile map. That's a pretty basic set of things that we should do. And let's just go ahead and do that, because I don't think that'll be too difficult to do. So, because those are sorts of things, again, that we have to kind of see how they work so that we can start to build an engine around these things. All right, so let's take a look at what we've got here in our code. Again, for the tile map, we just slammed in, and I think I said this yesterday very clearly, we're just doing exploratory code here, so you want to just do the simplest possible thing. Don't overcomplicate anything. Don't think about code cleanliness or any of these other things. You just want to get the simplest thing working and then build up from there. Okay. So, what I want to do here is I want to figure out some way when I move this guy, right? Because I've got a call here, this call right here. I essentially have something where I'm moving the player around, and I want to know whether, when I do this move, I want to be able to say if the move is invalid, right? If I would have moved into an area of the tile map that was occupied, I want to disallow that move from happening, right? I do not want the player to be able to go somewhere that they shouldn't be able to go. And so in order to do that, I need to look at the tile map, obviously, so I'm going to go ahead and put that tile map up there. But really what I need to do is I need to know for a player X and a player Y, I need to know whether the player is, where that X and Y is relative to the tile map. Because if you think about what we've got, right, we've got this tile map on the screen where the tiles themselves occupy several pixels, right? So the tiles and the pixels are not the same. And so what we have is we have a pixel location of the guy, and we want to map that pixel location. Like, let's say the pixel location is here, and this is the tile map coordinates, right, or something like this. We need a way of saying, for a particular pixel location of the guy, or a player location of the guy, we need to map him into where he is in the tile map, right? So I want to be able to pick that and go, oh, that's 3, 3 in the tile map, so that I can see if that location is occupied in the tile map or not, and stop the guy from going there, right? So let's go ahead and see if that's true. Let's go ahead and write something that will sort of do that check. Basically, we'll say, okay, let's see. I need to basically compute player tile X, and I need to compute player tile Y. And those are going to be computed off of these values. Now, I know, and I got to move these up here too, I know that our tiles are this wide and this high. I know that they start here and here. So the first thing that I need to do, right, and I guess I should do this on the diagram so it's clear, we know that right here, that upper corner is given by upper left X and upper left Y, right? So what I want to do is I want to turn whatever the player's position is into something that's relative to that first, right? I want to make it relative to the minimum X and Y of the actual map. So what I want to do is I want to subtract whatever their position is from this position, because that will give me the distance along x that I would have to go to get to where they are, right? Which is like that. And then the distance along y as well that I'd have to go to get to where they are. So that is what I want to do first. And again, those of you at home who know all sorts of things like vector math and that sort of stuff, don't worry, we are getting to all that stuff in coordinate systems, but I'm just trying to go through this from first principles so that everyone can see how we get to the final stuff that we want to do. So what I want to do is I want to make it relative to that. Right now, it's relative to the screen, right? We're talking about drawing the player at player X and player Y. If you remember, we computed where we were going to draw them. We computed it off this. So these are basically pixels. But we can't use pixels. We need to use map coordinates. And so the first thing is to make it relative to the origin of the map, right? Okay, so we do that. We say, let's go ahead and subtract those upper, that position up here again, upper left X, upper left Y, right? So I'm going to go ahead and subtract upper left X, upper left Y. And that will give me something relative to the corner of the tile map. Then what I want to do is know which of these buckets it falls into. Does it fall into the first bucket, second bucket, third bucket, right? And that is just a simple divide, right? If you imagine that this right here, right, is the tile width. Each one of these is one tile width. If I want to know how many tiles over I am, I just have to take his x-coordinate and divide it by that tile width, and it'll tell me 1, 2, 3, 4, right, if he's there. But it's going to give me a fractional value, right? So basically, if I divided this, if I divided where he is here by the tile width, I would get some value less than 1, right? Because it doesn't hit 1 till it gets to here, right? So if I were to truncate that value, remember we talked about truncation, where on the number line, right, you've got wherever you are on the number line, you go back to the next lowest number, right? If I were to truncate that number, that would give me the correct tile slot, 0. If I go over here, right, then if I were to truncate that, it would drop me down to 1. As soon as I go over this boundary, I'll start dropping back to 2. As soon as I go over this boundary, I'll start dropping back to 3. And as soon as I go over this boundary, I'll go to 4, right? So all I really need to do is divide by the tile width and then truncate, and I get which slot I go into. And I can do that for X and I can do that for Y and figure out where in my tile map I am, right? So if I divide by the tile width, and I divide by the tile height here, right, which happen to be the same, but I'm going to do the math as if they weren't, just so we can always decide to change the rectangular tiles at some point if we really wanted to, right? Oops, Emacs, a little overzealous there. And then I go ahead and do that truncation. So I'm going to go ahead and do the truncation here. So we'll go ahead and truncate. Now you notice I'm not rounding, right? I am not doing a round. I'm doing a truncation. And one thing that we might do too, this might be nice. Let's go ahead and do this. Let's call truncate real32, right? And that truncation just does this exact thing without the rounding, right? Make sense? So I'm going to go ahead and actually do it that way. These should all be inline, by the way. There's no real reason not to be. These are such trivial functions. So I'm going to make a truncate, which just basically does that. And that way we can see in our code, so instead of looking like a cast, it'll give a little more information to the person who's reading it, so they know that we were trying to do something very specific. We're trying to truncate. We're trying to do a truncation here, right? Now there's a bunch of things to discuss here again, but I have to kind of meter them out over time. So let's just focus on this for now. So I'm going to do this divide. This will actually give me the tile X, tile Y that I was looking for. And from there, I can now look up into this tile map thing and see. Now there's a problem, obviously, which is that I don't actually know whether it's going to be valid or not, right? I don't actually know whether I'm inside, because I could have had any values. I might be outside the tile map. So one thing that I probably should do is I should start off by saying, okay, and you know what? We also are trying to do a check here. So I want to do this. There we go. Okay. What I want to do is basically compute a speculative value. So whatever the new player Y and the new player X would be, right? I want to do those and then check those before I actually commit them to be the new player location, right? So I'm going to go ahead and compute those. I'm going to go ahead and check them. And so I'm just going to do an is valid. I'm going to assume it's false. And then I'm going to say if the player tile X is greater than or equal to whatever, so 0 and less than or equal to whatever the array size is here. So our tile map size was currently, and you know what, I could go ahead and do this right here. Tile map count x is 17, and tile map count y is 9, right? I can go ahead and make constants for those. So here's the tile map count x, x, and here's the tile map count y. There we go. And so I'm going to go ahead and check to make sure that I'm within those boundaries, right? So I'm going to say if we're greater than 0, so we're not off the left side, basically, and the player tile x is less than the tile map count x, and so I've got, oops, what's going on there? What's going on there? What did I do? Why are we not matching? Ugh. Emacs. Never ceases to disappoint these days. Okay, that was just an Emacs. It's got bugs and how it thinks that it thinks you're opening a template, and then it's awful. Anyway, okay. So there we go. Player tile y less than tile map count y, and there we go. So we're just going to see if these are within bounds, right? And if they're within the bounds that we're trying to that of our tile map, we can now look up in the tile map and see whether the tile map is occupied. Right? We can see whether there's a 1 or a 0 in there, right? So is valid, right? In fact, well, we can just do it explicitly too first. We can say tile map value is going to be equal to our tile map right here, and using the lookup that we actually just computed. So player tile y comes first, because again, these are in sort of inverse order. You look up the way that C's array syntax is this is the least significant part. And this is the most significant part of sort of the indexing into the array. So we want to look this way for x. That's this is x here, and this is y, right? Okay. So when we actually get that tile map value out, whether or not we can move there is essentially equal to whether or not that tile map value equals 0, because 0 means it's unoccupied, and then we can move there, right? Now, we've got other things. That's not going to be great because, well, there's reasons we'll see exactly. So we're going to probably want to do a little bit more than that. But for the moment, if that works, as long as it's valid, we can go ahead and accept those positions like this, right? So let's go ahead and do that. All right. And so we do have one problem right now, which is that our guy is not himself actually in the map, right? He starts way out there. So we kind of need to move him over here somewhere, right? So during initialization, basically, in here, right? I should probably move this all the way up to the top, huh? So during initialization, when we actually go and say the game is starting, what I want to do is I want to go into the game state and set this player X, player Y here, that when we first create it, to be something that's going to be at least somewhat useful. That's going to be a value that's not already standing in some place invalid. I'm just picking this number out of a hat. I don't know if it's actually going to be right. No, it's not. So let's try a little bit further. Since this is initialization, I can't use the restart trick here, unfortunately. Okay, so there we go. So now the guy moves around, and basically you can kind of see that I can't get into, right? I can't get into things that are blocked. But like I said, there's some weirdnesses there, such as the fact that, well, okay, so some of them are by design. Like we said before on the previous stream, we want to be able to eclipse things when we're standing on them, because we imagine that the guy will be a little sprite here and can eclipse kind of what's in front of it. So that's actually not too bad. But what we do want to do as well is we want to stop the guy from going into things like that. We want to take into account his width, because right now we're only checking the point that's actually the player location. We're only checking to see if that is moving into a tile invalid. That would be invalid. So he can go all the way like halfway in to something without getting stopped. So what we want to do is actually check that outer edge, right? We want to check to make sure that the outer edge is not going to hit something, right? So there's a couple ways that we could... Whoa. Oh, the flashing. Yeah, so that's pretty interesting. So we're going to have that, yeah. I wonder if we'll have to deal with that a little bit. So basically, I don't know if you can see that. We're kind of getting some flashing there. Because of the pat-blit blackness thing that I put in there, this pat-blit blackness, this thing, because that happens before the stretch DI bits, Windows will sometimes, if the page flit happened in between here, you'll just see the blackness before the stretch DI bits. So we kind of want to only actually clear the parts of the window that we're not drawing to instead of doing this. So we could set the clip region, I don't know, or we could clear the different pieces of it. You know, stuff that I really don't want to have to do right now because it's so irrelevant, but let's go ahead and do it anyway. So if I wanted to clear the 4 rectangles that would clear out the region that we're at, you could imagine just saying, you know, I don't know if you know what I'm saying here, but if we just cleared these rectangles, basically, instead of actually clearing the whole thing, that's a pretty quick way to just get around that problem. So if we did 0, 0 to window height to offset Y, basically, that would clear that top. This would clear that top piece. And then the bottom piece, of course, would be offset Y plus buffer height, and it would be the window width and whatever this is minus the window height, although we could actually just pass the window height because Windows will clip it for us there, so that's fine. And then here we have to clear the gutter on the left side. Again, we don't care if we overwrite anything, so it would be 0, 0 to window height and offset X, and then this will be offset X plus buffer width, and that'd clear all the way to there. Okay, so this is just complete nonsense that I've made here. Is that right? Yeah. I think that's correct. I don't actually know. Window width is not a member. Right, it's just width. So yeah. So all I was trying to do there, and I think I did it right. Again, I don't even want to go into detail because that was just randomness. So yeah, that looks right. So all I tried to do was just basically clear this rectangle here, this rectangle here, this rectangle here, and this rectangle here, right? So that we'd never overwrite this and get that annoying flashing. That was literally all I just did because it was going to annoy me, so I decided to get rid of it. All right. So anyway, we're colliding with the tile map now, and we just want to do a little bit better job. Again, we're going to have to do stuff way better than what we're doing right now eventually, but again, just to sort of try and build up from first principles, I'm just showing you the stupidest possible thing that you could do, right? All right, so let's try and at least make it so that when we hit the edges that we stop. So what's the easiest way to do that? And this is, I'm hoping this leads kind of conveniently into what I wanted to talk about, and I think it will, as far as this issue is concerned. So if we start to look at this, right, what's a real easy way, if you just think for a second, what's a real easy way we could fix the problem that I was just talking about? And I'll go ahead and bring this back up again. So I'm talking about this problem. I've got this guy and he runs into the wall, right? And I want to stop him here, but he runs in that far, right? And the same happens on the other side, right? So what's an easy way that I could make it so that that stopped happening, right? What could I do to prevent that? Well, one really simple thing we could do is to just check, because we already wrote the code to check up one point against the tile map. I could just check the 2 other points, right? So that'd be real easy to do, except for the fact that I got to cut and paste all this code, right? I got to cut and paste this whole thing. So it would be nice, right, to pull this out into a thing that just checks a point in the tile map, right? That would be pretty handy. So that seems like a pretty good compression to make here, just to start with. It seems pretty obvious. If I want to check multiple points, let's just make a function that returns this is valid for the point, right? So let's go ahead and do that, and let's see where that leads us, right? So I'm going to go ahead and make a function here that just says is point, let's say, occupied, or something like that, right? I don't know, something like this. So, or maybe is tile map point empty, right? So what I want to do is I want to say, all right, I'm going to take in now whatever this x and y is. So it's a test x and a test y, right? I'm going to take those in, a test x and a test y, and I want to return whether or not it was empty or not, right? So is it empty? If it's empty, I'm going to say that it's not empty, and then we'll see if the tile map value equals 0, then we'll say that it is empty, right? And I'm going to return whether or not it's empty, right? Does that make sense? Pretty straightforward there. So you can see if I compile this, we've got problems, though relatively obvious problems. And that is that there's a bunch of data about the tile map, and that data isn't really easy to pass here. Like, let's say I'm going to need the upper left, the upper left x, the upper left y. I'm going to need the width and the height of the tile map. I'm going to need the tile map itself. So you can sort of start to see, this is an indication to you, again, when we're talking about architecture, this is an indication to you of what things go together in terms of what you will want to pass around, right? And although in this case, maybe you could have guessed these things, it is always easier and always more accurate to let them come about in exactly the way that they just did, right? Okay, we don't have to do any guesswork. We basically know that functions like this are gonna do math on the tile map, right, are gonna need these exact things, because they won't be able to do any math without it. They're gonna need, well, you know what, I've got them defined right here, right? They're gonna need all that stuff. The upper left x, the upper left y, the tile width, the tile height, right? They're gonna need that. So let's just go ahead and say that that's part of some structure that we call a tile map, let's say. We don't know what we're gonna call it yet, but let's call it that for now. So if we pass the tile map, that just makes it convenient for this thing to get access to all of the aspects of a tile map that it's going to need to do its job, right? And so again, this is just an organic way to figure that out. So we don't pre-plan, we don't guess, we know. And knowing is always better than guessing. So we go ahead and we do that, and let's go ahead and compile that. You can see we need some more data here. We need the count, right? We need something in here that'll tell us basically the tile map, well, tile map count. Let's call it dimension. Dimension x, tile map. Well, no, it's count x is better, so we know, yeah. Tile map count y. Let's just have those two in there, right? And so then we'll change these, tile map like that, tile map count x, and this will be tile map, well, and you know what? We could probably get rid of the word tile map because it's already in there, right? So we can just do count x, count y. There we go. And now we have a kind of nicely functioning thing. We just don't know where to get the actual tile map data from. Well, we can totally do that. We can totally put the tile map in here. But we have a problem, which is that technically if we want this thing to be relatively flexible and not care what size the tile map is, we want to probably make it so that it doesn't hard code in C what the width and height are. So we kind of need to turn this into the same accessor like we were doing up here with our pixels, right? Where we do a bytes per pixel, where we do this kind of a thing, where we do math to unpack the x and y, basically, to figure out where in the tile map we are with an x and a y. Now, it's the same exact math that we used before, right? If we have that tile map, and this is, I guess, is what we want to call these the tiles, I suppose. If we go in the tile map and we access the tiles, we want to do the same access we were doing before. We know that the x just works the way that it always does. It steps one through, so we can just add the x in, because for every x tile you go, you're going to go over one entry in the tile map table. But since we are now basically turning a 2D thing into a 1D thing, that y, every time you go up one in y, you're going to have to advance by the entire tile map count in x, right? And I'm going to diagram this out for you in a second, but I just want to make sure that compiles first. So there you go. Okay. And so what I'm talking about here is what we did in excuse me. Let's see here. Let me go ahead and delete this guy. There we go. So what we did, right, is originally we said we wanted tile map, and we had sort of a height and a width count, right? And we had C basically do the addressing for us, right? So we would fill in a Y when we wanted to access it, and we'd fill in an X, and we would just get out an entry in the tile map, right? And so we just conceptualized this as a 2D thing, right? Where we would plug in an X value that goes this way, and we plug in a Y value that goes this way, and that was our conceptualization of it, and C did it for us. But what we need to do is we needed to say, all right, we're no longer going to declare what the size of it is. We're just going to have a pointer. So it could be any size we want later on. And in order to do that, we need to basically have a way to do our own dynamic array accessing that will essentially map this array to some arbitrary chunk of memory such that we can still access it in X and Y. And so what we want to do that, right, is we want to use that same Z pattern that I've been talking about a lot lately, right? Basically, we stick the row, the first row of things into the first second, third, fourth, fifth, sixth, seventh entries or whatever, right? Then when we get to the end of a row, we start the next row. So we just pack the rows in. So basically this row, right? This row maps into the first part of the buffer, right? Then this row maps into the next part of the buffer, right? And so on and so forth till we've had all the rows. So that leads us to the computation that we need to get when we want to access something in here, when we want to change an HW, right, into something that's just one accessor, right? So we had an XY, and we want to change this into a single thing, like an N. We just want to have one value that we enter. How do we do that? Well, it is always going to unwind in the same way when we unpack those rows. X is the smallest accessor. It moves by 1. So basically our X, remember, because our X was, this is our X. So if we were accessing into the first row of X, we would always just use whatever the index actually is. So we just use X, right? So we're going to add X to our accessor when we have to compute what our accessor is. Oops, I shouldn't do that yet. So if we have tile map, we know that we add X, and that moves us through it. But for Y, we now know that for every 1 in Y we would move a whole set of X's. We'd move a whole row. So we need to take that width, right? And we need to multiply the Y times the width to know how far to go. And that leads us to the canonical form of how to access a 1D thing in a 2D way. It's always the least significant accessor, right? Plus the next least significant accessor times however large this thing was, however large the maximum value, the number of elements in whatever this thing was accessing. So the number of elements in a row, right, which is the width in our case. And we could keep going. We could have a 3-dimensional thing, right? We could have a thing that was packed 3-dimensionally, and we just have it again. We just have z times width times height, right, plus y times width plus x, right? So you just keep multiplying dimensions on, because remember, if we were going in z, we'd have to account for an entire 2-dimensional piece that was packed in. So we'd have to do the width times the height is how far you'd move in z to get to the next one, right? And so this just chains out forever to however many dimensions you want. Packing n dimensions into 1D is just this relationship that happens, and you'll see it everywhere in code. So that's all we're doing here, right? And you can see that this is the way, where is it? That this is the way that I've written it out, right? You can see that I wrote out whatever that count x is. Every time you move some 1 in y, you're going to move that many in x, however many x's there are total in one line. And then the x, of course, is just its own incrementer. So that's sort of that how to pack 2D things into a 1D thing, or ND things, really. That is what's going on there. So hopefully that makes some sense to you. All right, so when we do that, we now have a function that we can pass a tile map to, and then we can do our testing, right? And so let's just do the basic version first. If I have my tile map here, I'm going to declare one of these tile maps, right? I need to go ahead and define all of these values, right? So let's go ahead and do that just real quickly here. Let's say tile map count x, count y, upper left, like this. You see, blah, 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 right? No big deal. Everything's fine. And then I'm just going to go ahead and move all of this stuff into there. So we basically have, you know what, I can move these directly into there for now. So we basically have, this is 60, 60, the upper left x, and upper left y's are there. There we go. And the tiles, these are our tiles now. Our tiles equals tiles. And of course we'll have to cast that because now it's 1D, all right? Because this is a 2D array, and C would complain if we cast it. Well, you know what? I'll show you the error just so you can see it. And then we've got our counts in here. Let's go ahead and do that. Count and count. And that is really all we have to do. That is it. So if we go down here, and now we want to do our tile map work, we should, and you know what? Let's go ahead and just change all these guys. Tile map, anything else? Tile map, tile map, tile map. That's good. Tile map. Let me see what else we got to do here. Let the compiler guide you. Well, we're going to talk about that in a second. There we go. Tile width, tile height, and tiles. Okay. Okay. So I think we're good there. There we go. So this is the cast that I wanted to talk about, right? Basically what I was saying is that a 2D array, something declared as a 2D array in C cannot be cast as something that's a 1D array. And so we have to tell it that it's okay. We're going to treat that as a 1D array, like it's fine. Don't worry about it. Okay, and so we haven't actually done anything yet, so our code is still running exactly the way that it was before, but now we've packed the thing in there. So let's go ahead and say, all right, let's replace the check we were doing, right, with the new check. So we've got this function here. We've got isTileMapPointEmpty. So what we want to do is replace our isValid, that work we were doing for isValid. We want to replace that by just calling the tilemap query that we wrote with the new one. Right, so there we go. Oops. We're going to delete all this stuff because this is the same. We don't need it anymore because we just wrote a function to do it. And in fact, we can even just kind of wrap this in there. We'll just say isTileMapPointEmpty, and then if it is, then we'll go ahead and use it. So there we go, and you can see that it works now that we've factored it out, and it works exactly the way that it did. So if we want to now, we can call this on multiple points. We can just start adding points to test, like if we want to, right? We can just say, all right, let's test a bunch of different points. Let's test the new player x minus the player width, right? Half the player width. So that would be, that would be this part, this corner of the player. And let's go ahead and do the other corner as well, right? It's going to be here. Of course, I've got to move him out of there first so he doesn't get stuck. That's a good idea. And so we'll test all of those. And if we're going to say they all have to be in an empty space in order for this to work, right? And so we just need to move the player width up here. Again, this is sort of, you should feel those tingles. You can see the code start to move into sort of aggregate, which is what we're trying to do here. So there we go. And now, when I move in theory, you see how I stopped there? I couldn't get in there. Stop again, right? And so now we're sort of abutting against the tile, and we can't go into it, right? So we're starting to get somewhere. We've got some information about how we should make things work. We're sort of getting a little closer, right? You would never want this game to play like this. It feels awful. You get stuck on the sides and all that stuff. So we're real far from a good game. But, hopefully you can see how we're making sort of slow and steady progress towards the design that we want, right? Baby steps, but the steps are easy to do and really easy to understand. And that's what you want to do when you're coding. Baby steps that are concrete and where you have good information about whether your design is going in a good way, a good direction, or a bad direction, right? All right. So now that we've got this, the other thing that I said that I wanted to do, right, is if the player moves off of the tile map, I want them to move into a new tile map, right? So let's think about what has to happen in order for that to occur. Okay. So, in order for that to occur, we know one thing right off the bat, which is this tile map here is not going to be able to be static. We're going to need multiple of them, right? And so in order to do that, we've already set ourselves up for that a little bit because we've got this tile map here. So I'm going to go ahead and promote that tile map out to the H file so that I can see it and understand it. So there we go. We've got the tile map, and that's all good. But we're going to need more tile maps, right? We're going to need, let's say, at least 4 tile maps so that you can walk around between a couple of these tile maps. So in order to do that, what I'm going to do is I'm going to define more than one of them, right? I'm going to define more than one of these tile maps, exactly how you might think. You know what, let's just do 2, because 2 will be easier for us. All right. So I'm going to have 2 things here. I'm going to have tiles 0, right? And there's, of course, Emacs messing up the indentation. Thank you, Emacs. There we go, and tiles 1. So now I have 2 tile maps, and I'm going to go ahead and make these semi-coherent. So I'm going to basically say, all right, there's no doors on these except for the doors that would actually lead to a valid tile map on the other side. So they're going to be like above and below each other. So you can go out the top of this one because there's 0 there, and you'll come in on the bottom, right? Make sense? Yeah. So should be good. So basically, I'm just going to define 2 tile maps here. I'm going to define this tile map here, right? And I'm going to define this tile map here. And I'm going to do the shorthand of just cloning this tile map because it's got the stuff in it that we want. Yeah, and then I'll just go ahead and change the tiles pointer here, right? So I'm going to go ahead and say, all right, we've got the tile map to tiles pointer is going to point to, you know what, let's also do this. Let's say that we've got two of them. Let's just make them an array. So we've got tile map 2, right, brackets 2. So this is tile map 0. It's going to do these things like that. I'm going to say that tile map 1 equals tiles 1. So there we go. There we go. 0, tile map there. You went 32. Okay. And I need to clone the other values that are in the tile map here. And that should also tell you something. The fact that I have to clone them is suspicious, right? So keep that in mind. Again, always just kind of look at things and be aware of what is happening and where things are going and how they're doing it. Let's go ahead and compile that. Let's see here. What is, oh, right, tile map. All right, so we've already got, so I should call this tile maps. So what we want to do now is we're kind of storing our tile maps. We've got 2 tile maps, one on top of the other. I should probably make them look a bit different. So I'm going to make one of them completely empty and leave the other one basically as it was, right? So this one's going to be completely empty, and the other one is going to be exactly as it was. So there we go. Let's get rid of all of those. We'll get rid of this. There's all of our ones are gone. Okay. So what I want to do now is say that I've got these tile maps, and then I'm just going to say that there's a current tile map that is the tile map that we're on, right? And we'll say that that's tile, it's going to point to tile maps 0 for now. And so everyone who was using tile map dot below me is now going to use tile map arrow, right? It's going to reference some pointer to a tile map, but it's not really necessarily going to know which tile map it is. And so these are going to work like that, right? And if I recompile this in theory, what is the problem here? There we go. If I recompile this in theory, I should be able to, what are you complaining about? Oh, right. So this guy also needs to access a tile. So this is another thing that we might want to think of. So we already have the code for accessing a tile, right? We wrote it up here. It's this thing, right? So we may want to also pull that out, which is basically get tile value, right? So we can pass in a tile map and the sort of int32 tile x, int32 tile y, right? What we may want to do is just say, all right, let's go ahead and pass it in there, and let's call that direct, so, or unchecked, so that we know that we're assuming that we've already done a check on it to see that it was valid before we actually did it. So we're going to do something that does this, right? There's our tile y, there's our tile x, and this could be an inline function because it's nice and tiny, and we're just going to return that tile map value. Right? So now we have a way to query in, and we don't have to know about this code anymore. We can just pass in a thing where we actually ask for our player tile x and our player tile y in a convenient way, and we can get it out. So we just pulled that out there, right? Let's see here. So now this guy can use the same thing, get tile map value unchecked, and it can go ahead and ask for the column and the row, and it will do that access right there. So we still are running exactly as we would expect to run. It's all good, except now you'll notice our doors are gone, except for the bottom door, which is good. So all we need to do now is make it so that when we come out here, when we walk out of here, we will be able to leave and move on to the next screen, right? So what we need to think about is the fact that these tile maps are sort of, we kind of want to think about the tile maps as having, you know, continuity, so that almost as if it's one big tile map. But we probably don't want to make it just one big tile map. And the reason for that is we would waste a ton of space in the cases where the tile maps are not dense. And let me go ahead and show you what I mean by that. So one way to do this, that would be pretty easy, right, is to say, all right, essentially what we have when we have all of these tile maps, right, is like we've got these 2 tile maps, they're stacked on top of each other like this, right? And I don't know, I've got it looking kind of like this. I've got this put in there. There's a barrier here, but there's a door there that you can go through, right? Looks like that. So one way to do this, right, would be to make the whole thing, this whole thing could be one tile map, right? And we're just viewing a subsection of the tile map. We could do that. The problem with that is what happens when things get absolutely massive. Like, let's say that we end up with a fully 3D sort of structure for these tile maps, where we've basically got, you know, imagine each of these as a tile map, and then there's tile maps on top of tile maps, right? There's like, you go up a level, and there's tile maps here, and there's tile maps there. This thing goes on extremely far. There's like 400 tile maps in this direction, right? And then there's a 300 tile maps in this direction. But they're very sparse. Like, we don't fill them all in. Like, there's no tile maps in here. Most of the levels are not, you know, maybe there's 20 tile maps that go up. There's like ladders that go up and up and up on one spot of the map. But, you know, we don't actually have that anywhere else. So they're going to be very sparse, and it could be very sprawling and sparse. And so what you don't want to do is you don't want to store everything as a giant 3D voxel, basically kind of a thing, where the entire map for the whole world is stored in some giant array. Because, as we've seen, how much space does it take to store something? Well, a linear thing, right, something that's just things along a line, right, is just however long the line is, right? If the line is n long, then it's going to be n space to fill it. So if we have to store, you know, I don't know, let's say we store 1,000 tiles in a line, then we basically have 1,000 times the size of a tile. However big, however much we need to store in a tile, that's how big it would be, right? And you can pretty much see that when you have something like this, even if this was like, you know, 10,000 or something, I mean, how many are really going to go across? This never is going to get to a particularly big value. Even if tiles were, you know, a megabyte or something. Well, a megabyte's a little bit large. Let's say they were a kilobyte, 1K per tile, right? Then really all we have here is we've got a 10 megabyte set to store that whole thing, right? So it's just not that big, right? It's not a big deal. But as soon as you start adding more dimensions in there, as soon as you add another dimension, where you're going to do 2 dimensions here, right? If you have another 10,000, it becomes 10,000 squared, right? It's 10,000 times 10,000 to store it, because for every 10,000 of these you've got 10,000 rows now. So you've got like 10,000 rows of 10,000 entries. And these numbers get big really fast, right? In so much as you cannot make a line get that big, you can make a square get big really quickly in terms of how many interior tiles it has. And if we go one further and go to cubed, right? So now we've got, essentially we're storing a 3D world, right? Where we've got, you know, you can go up ladders and down ladders, right? So you can move up tile maps and down tile maps. Storing that is now cubed in however large you want the world to be in any given direction, right? So again, since we only want to be able to store stuff where stuff actually exists in the world. If there's a tower in the world and you can go up 20 flights in it, we want to only have to store the 20 flights. We don't want to have to store 20 flights virtually for every square on the map, for every tile map for every, you know, section of the tile map on the world, because there might be nothing there. So you're just storing empty air. So essentially what we want to do is we want to be able to say we only have tile maps. We only have a 2D tile map section where one actually exists in the world, so that we can feel free to have long, windy things and tall things in places where we want them without paying the cost of that everywhere and making it prohibitive, right? And so, you know, that's just prevents you from having to pack your world so that everything is densely packed in one area. You can make like kind of large sprawling things and still take up the same amount of memory. And that's called sparse storage. Sparse is the word we use for that, because you can say that something is dense, which means that like all the entries are there, or you can say that something is sparse, which is that you have a storage scheme that doesn't cost much to store nothingness, right? So what we're looking for is something sparse that lets us store tile map sections only where the player can actually walk to, and not waste a bunch of memory storing them where they're not. And so again, that's why I can't just make a giant 2D tile map of the entire overworld, because I may want to have long, thin things extending out through parts of the world, and if we were to actually try to store tiles for the entire world as if it was a giant filled-in 2D grid, we would blow out memory too quickly or something like that, right? Okay, so we want some kind of sparse storage for this thing. So what I want to do is basically say, okay, I would like my tile map queries, I'd like to be able to still do a query as if I was querying stuff sort of uniformly, but I would like to basically say, is it okay for the player to move outside of this door, right? Can he move down? What's down here, right? I want to be able to know the answer to that question. And so in order to know the answer to that question, what that means is that going off the edge of one tile map should bring me onto the next tile map. And we only have 10 minutes here, which is a little tight. So I'm wondering if I should. I would like to start this. I would like to start this, but I don't know if I'll have time. We'll see what we can do. So what I want to do here, right? We can sort of see what happens. What I want to say here is, okay, so you can see this is tile map point empty thing. It's only got one tile map, right? And so it wouldn't be able to look at a different tile map. So what I kind of need to do is I need to be able to do that in a way that asks about more than one tile map, right? I need to be able to ask about this in a way that's more than one tile map. So you can already see, I already have a hint, which is I know I want to be able to do these point queries easily. So I basically want a function that works exactly like, oops, let's not move that, that works exactly like this. But I don't actually want it to only access one tile map at a time. I want it to access the whole world's worth of tile maps, right? So if you imagine what this would look like in a thing that says, you know, if I clone this function basically, and I say something like, is world point empty, right? And I want to be able to pass this sort of a test x and a test y, and I want to be able to know, you know, essentially what's going to happen to the point, considering the whole universe of tile maps that we may have defined, right? What I need to do is figure out a way to sort of get it so that the coordinates of this thing, we can even, you know, we can look at it directly in here, right? You just imagine cloning this function. When we come in here and we use the test x and the test y, they are relative to some tile map, right? They're relative to some tile map in the world of tile maps. But if I go off that tile map, I would be relative to some other tile map. So what I want to do is, instead of only considering the case, so, you know, empty was set to false, instead of just assuming that a tile is not empty that a tile is like filled, which is what we're doing, if it does not exist inside this tile map, what I want to do is use these cases more intelligently to figure out what tile map I would be in, right? And ask that tile map. Does that make sense? So what we need to do is introduce a higher level of coordinate here. We need to introduce sort of where we are in tile map space, right? And so what you can see is I started to do that here. I said we've got two tile maps. We've got tile map 0 and tile map 1. So you can imagine saying we have some index that's where in tile map space we actually were, right? So instead of passing this in a tile map, what we need to do is pass in, like, you know, basically the world map, let's say, world map, or just world. Let's call it just world. We're going to pass in the world here, and we're going to pass in some kind of notion of which tile map x and y we are on. Now, at the minute, and you know what, I probably should, just to show the full thing here, I probably should go ahead and say that we actually have 4 tile maps, right? Because that way I can show an x and a y happening. Okay. So, well, you know what I'm saying, this kind of thing, right? Does that make sense? Yeah, okay. So let's say I go ahead and blow that out, and these are all empty again. So I've got tile maps 2 and 3. Okay, and so let's pretend that we've got this guy here, and this is tiles 0, 0. And this is going to be, so that's like, I'm going to say that's x and y, basically. So basically we've got tiles x and y, so this would be right below this guy. And so then both of these guys will be able to exit off the side, like this. And these guys will be coming in on the side, that. So now we've got tiles 1, 0 and 1, 1. And so that, again, 1, 0 would be on the top, so it would be that way, and the other one would be on the bottom. So it looks like that. No, that's a mistake. Why did I do that? Should be, oops, should be there. Shouldn't it? Yes. Yes. Oh, no, I'm right. Never mind. Getting confused by my own scheme. So I'm just kind of making this by hand here. There you go. And so, you know, these guys will be in that pattern. And so now I've got my tile maps here, and I'm going to go ahead and lay them out manually again, just because we're not at the point yet where I really know what I want from everything. So we can go ahead and do this for all of these, right? So we have our tiles. We've got our, excuse me, our mother tile essentially, so we're going to go ahead and clone that tile map so that everyone has their values initialized, right? And we haven't quite finished pulling all the stuff out that we want to, but we're going to go ahead and just do the basics here. So this is 0, 0, 1, 0, 1, 1, like that. And we're just going to initialize them exactly to what we just labeled them as in the other thing. So you can see, there we go. Oops, got to finish the world stuff first. Skip over that. Skip over that. I don't care about any of this. Okay, there we go. And there we go. All right. So we've got a bunch of work to do here, right? And this is why I said I didn't know if I want to start this yet, because we may leave things in a broken state today, which would be unfortunate, but sometimes you got to do that. Basically, what we need to do now is we need to sort of have something that contains all of our tile maps, right? And so I'm just going to say that we've got that world struct, right? We've got that world struct, and we don't really know what it contains yet, but we know at the very least it's got to contain these tile maps, right? It's got to contain all these tile maps. So basically, we've got the tile maps here, and we have to sort of have that pointer. And the only thing we know so far is that we're going to have to store all these tile maps, and we're going to have them in something like this world struct so that I can pass them around to things that need to be able to work with them. So we've got tile maps, and the tile maps are going to equal a pointer to our tile map struct, right? So there we go. So inside the world here, now we sort of have something where we're going to go, all right, we have a tile map X and a tile map Y that we're going to use as coordinates to look up into this thing. So we're going to have to use the exact same math that we just did, this kind of a strided lookup in sort of this get tile value unchecked, right? And that is something that we're going to want to do again. We're just going to clone that function for getting the tile map out of the world, right? So we have a world structure, and we're going to have a tile map X and a tile map Y that we are going to use to pull out the world coordinate. So again, we know exactly what this looks like, right? We're going to have a thing where we essentially have a count X and a count Y, and we're going to look up a tile map in here. Now, what we said, we've got a problem, you know, like I said, this is still going to be dense so far, but we'll kind of, yeah. I'm running out of time on the stream is basically what it boils down to. I won't be able to get to the sparseness, so we'll just drop a thing in here to do beginner's sparseness, basically, which we have to do. Okay, so basically what I want to do here is I want to be able to say, all right, get me the tile map that goes with some coordinates for the tile map. And all that's going to do is exactly the same math we did before. It's going to look up into the tile maps using the tile map Y and the tile map X, and it's going to use essentially counts that we've put in there that says how many across each one is, right? So we've basically got a tile map count X and a tile map count Y, and that'll go ahead and look up an actual tile map like this, right? And we will return that tile map like that. And now what we probably want to do is make sure that is guarded itself. So we'll look to see whether the tile map X and tile map Y are in bounds, again, using the exact same math that we were using before. Nothing out of the ordinary going on here, like that. The world, and there we go. Set the tile map. Oops, like that. And same thing for Y. So there's our Ys, right? There we go. So we've got our get tile map function, and what that can do is that'll now give us a tile map, right? There's our, oops, world point. There we go. That'll give us a tile map by saying whatever the tile x and y that we had there. There we go. Get tile map. Whatever that tile x and y that we get passed in, we're going to look up what the map is that corresponds to that tile map x and y, right? We're going to say if that tile map is valid, if there was actually tile map at that location, then we're going to do this thing in that tile map, right? Now there's a bunch of stuff that, like I said, we're out of time on the stream. There's a bunch of stuff we still have to fix, which is unfortunate, but I'm just going to get this back to compiling, and then we will start the Q&A. And tomorrow we will finish talking about all of the stuff that we need to do to make this actually work properly. Okay, so what did I forget to do? Tile map count x, tile map count y, tile map count x, tile map count y. What is it? What is it complaining about? Not a member. Oh yes, this is actually the world pointer there. Cannot convert to between. Oh yeah, this is totally that's just copy pasta, as people say, which is hard for me to deal with when I'm talking on the stream. It's hard for me to concentrate on making sure that I do my basic substitutions correctly, which is unfortunate. All right, so we return the tile map, and this thing needs to return a tile map pointer, right? There we go. Okay, so where are we at here? We're still running properly. Okay, so I want to start the Q&A, but I'm just going to briefly say where we ended up, and then tomorrow I'll recap it. So basically, all we're trying to do here is extend our notion of tile maps out to having multiple tile maps, right? And so right now, we're still doing everything as if we're just on this one tile map, but what we want to do is be able to move between tile maps, so we introduced a second layer of coordinates. That's our tile map x and y, and that's going to tell us where in the tile maps we are so we can pull out the right tile map. Now, you'll notice there's some odd things here, right? Like, we've still got upper left and upper. This is like a rendering coordinate, really, and some stuff that doesn't really make sense for the circumstance. And so we definitely want to kind of start looking at these and seeing if these really should be in here, or if these should be in the world and stuff like that. And we also have some stuff to think about in terms of what those mean versus pixels. So we've got a lot of stuff to work at here. So I'm not going to try and explain any more of that, because we need all day, I think, tomorrow to explain all what's going on there and move on. But for now, let's end with that, because like I said, we're still in a good working state. I think even if we restart from the beginning, we're in a good working state. And so that's a fine way to leave it. And then tomorrow we will concentrate on being able to move between our tile maps, which will be a great place to end the week, actually, because then we've got a guy moving around a little world, and that sort of clears the way for starting to get into more bigger and badder stuff. All right, let's start the Q&A, basically. I think now would be a good time to start the Q&A. So let me go ahead and go in and put the filter on. So please put Q: in front of your questions, and keep the questions and stuff we did on the stream today. If you have questions like, how do I get into the game industry, or what language are you programming in, and stuff like that, please come to a pre-stream, because before the stream starts, I answer all kinds of questions, like questions about anything. And so, yeah, so basically anything, please keep the questions in the post-stream to being stuff that's on the code we did today or code that we've done in a previous day. Okay. And John Blow mentions that we haven't initialized any of the world stuff, and he is correct. We haven't yet. I probably should do that in case we forget tomorrow and wonder what's going on. We should probably initialize these to actually be what they actually are so far. So there you go. Thank you, John. Let's see. Why does player sometimes stop a pixel away from the wall? That's an excellent question, and something that we'll be getting into a lot more later when we do like a proper movement model for the player. The reason is because if you look at what's happening here, well, you know what? Let's go ahead and step into the code actually, and I can show you exactly why it's happening. So if I open up, where is Handmade? Where's handmade.cpp? It's not in here. All right, so let me just we'll break inside game update and render. Game update and render, so the breakpoint. Let's see. Oh, yes. Sorry. Gotta rebuild that guy. There we go. All right. So let's go ahead and break in here, and I can show you essentially what's going on there. So if you take a look, let's how should I do this? Let me grab the controller. We don't have the controller. I was trying to figure out how I can stop this in a way that makes sense. Because I want to stop it mid-move. Oh! Right. I forgot. We planned for this. I already am at the point where I can do this. I'm going to have this guy moving forwards. I'm going to set the loop point, right? And then I'm going to reset the loop point. So there we go. Perfect example of how we can use our loop point. So our guy is moving this way, right? I'm going to go ahead and set a breakpoint in here, and we're going to look at the values, right? So I come in here, and we look at what our D player X and our D player Y is, right? So our D player X and D player Y are going to be 64 when the player, if the player's moving a direction, like it's going to be like 64x, right? So he's going to move 64 pixels a second, right? We're going to take the input for the frame, input dt for a frame, right? We're gonna multiply that by the D player X, right? So we're going to multiply this value times D player X, and that's how far we're going to try to move them. It's 2 pixels, right? 2 pixels. So the new player X and the new player Y are 2 pixels away from where they were on the previous frame, on any given frame, okay? So what will happen is, in the case where we cannot move the player because the new point is inside the wall, he could stop 1 pixel away from the wall because he's trying to move 2 pixels forward. It could be that he could have moved 1 more pixel and not been inside the wall. Make sense? So when he goes forwards, you'll note he's always moving 2 pixels. He could have literally that happen. So I'm gonna stop the looping playback. So when we get into this situation, in that case, he happened to end right on a pixel. The moving 2 pixels at a time happened to end him in the right spot. But in other circumstances, he might not. So trying to think if there's a good way to do that. I think since this is even, it will only, yeah, there we go. Right? And so the way we would fix that simply, like we're not going to use this as the actual player movement code. We're trying to build it, build up to it. But if you wanted to fix that, right, you could imagine how you might want to do it. You would want to figure out if you could still move the player some shorter distance and not hit the wall, right? We could do something trivial and weird if we wanted to, right? We could go in here and do something crazy like, and this is not, I would not recommend doing this, but if we wanted to, right? We could do something like this. Bool 32 moved player, right? Moved player equals false. While not moved player, or maybe something more like for int try equals 0, try is less than 4, plus try, and we'll leave not moved player in there, something like this. And what we could do here, and again, this is not at all what you want to do, but I'm just kind of illustrate to you further what's actually happening in the code. We could try to move the player. If we can't move the player, if we can, we say moved player equals true, and we break out of the loop. If we can't, then we try making a smaller, we try going a little bit less. So we say d player x, times equals, 0.8 or something. So we move it a little, we just reduce the amount that we try to move, right? Does that make sense? And so now when we move, you can see I butt right back up to the every time, right? I don't stop that 1 pixel away, because what it does is it gets there, it gets to the point where it has the problem, and it's 1 away, right? Oh, well, or maybe not. That's not working. It should work. Let's see what happened there. What did I do? What did I do wrong? This should have worked. Let's take a look in there. I want to see what's going on. So I'm gonna set a breakpoint in here. What? What happened? Why can I not set a breakpoint? Is this MSVC not loading our PDB? What is the problem? Is this just me being stupid? It may be me being stupid. I want to see what happens if I rebuild this. That would suck if MSVC can't handle us rebuilding our PDB. Ugh. That's awful. That's really unfortunate that that's true. Well, anyway, I guess I can see what's going on here now anyways, so I'll double check that the bug is still there. So I wonder if it just didn't, yeah, so the bug's still there, so that's fine. So I can still find the bug. So it reloads our code, but it won't reload our PDB, it won't reload our debug info, so it can't set a breakpoint properly, or what's the deal? Is this just further MSVC being lousy at its job? That's unfortunate. Well, anyway, so you can see there I'm not going all the way up. I'm stopping 1 pixel away on that one. So let me take a look and see what happens during that. So when I hit here, right, where's my player X? So here's my game state. I'm going to take a look at it. Player X, player Y, right? And I now have a D player X and a D player Y of 0 and negative 64. And I want to go ahead and see what those are. I want to see what that Y value is. So it's negative 2.1. So we were unable to do the move on 2 pixels. So now I'm going to go ahead and make it less. So it's going to be 1.7 pixels that it's going to try to move now. So now it tries to do that, and then it reduces it again. Oh, so it just never reduces it quite low enough, I guess is the problem. Or no, it does it? Oh, no, it doesn't quite. So it just needed a couple more tries. Let's see if that solves the problem there. I'm kind of disturbed that MSVC won't reload our PDB, though. That's really annoying. That's really, really annoying. Okay, so I think we are now at the point where we're stopping, yeah, sort of at the right places, I believe. I should probably add some kind of a key to make us move a little faster through. Yeah, so you can kind of see what I'm talking about here, right? Yeah. So basically that's just a really cheesy way of saying, if you can't do the move that you were trying to do, try moving a little less. And basically this all comes from the fact that we're not doing the movement continuously, right? Essentially, what we would want to do, and this is the sort of stuff that we'll be getting into later, is if we have an obstacle of some kind, and we have a player, and the player is trying to move between two, this is over the time step, the player should move from here to here. What we want to do is we don't want to test this and say, is this valid or not, and then use that, right? And there's 2 reasons we don't want to do that, right? And let's say this is our obstacle, right? There's 2 reasons we don't want to do it. One is the one that you already asked about, which is that if the move can't happen and we just deny it flat out, then he's standing here, but really he should be standing right here. We wanted him to move as far as he could in that direction, right? So that's a problem, right? That's problem 1. But we've got another problem, and that is the thin wall problem. So let's say we've got a thing that basically looks like this. The player is here, and the time step would move him here. Well, if all we do is check the destination that he goes to, he'll tunnel right on through that wall. And that's a gameplay problem. He's not supposed to be able to tunnel through that wall. Furthermore, it creates a time-dependent tunneling problem. At 30 frames a second, maybe that's how far he moves. But at 60 frames a second, he only moves half that far. That means for people playing at 60 frames a second, they can't go through the wall. And for people who are playing at 30 frames a second, they can. So that's total, no, like all bad, right? So I want to underscore, just in case it wasn't clear, that like this is not, we don't want to be doing any of this stuff in the final game. This is just doing the simplest possible thing so that we can sort of see how to start structuring like the storage of the game, structures and that sort of stuff, and just to get things working in a reasonable sort of fashion. And so we're just going to leave that bug in there for now because we'll be doing different things for the player movement system when we go to actually tune it, if that makes sense. It almost sounds like you could get the wrong tile map when trying to move between tile maps with the function you just did. I'm not sure exactly what that means. Sorry. Let's see. Are your variables for tile maps too similar to each other, or am I just easily confused? I wouldn't say that you're too easily confused, because one of the next things that we'll be doing, obviously, is like having all these x's and y's and widths and heights and stuff can get confusing. And so one of the things we'll be doing probably not tomorrow, but next week, is introducing structures that help manage those things. Like we'll be introducing vectors and things like that to try and simplify these sorts of things. So yeah, I mean, I would say yes, they are confusing, and that is a good thing to notice because that is something that we will be addressing as we go forward. But I can only address one thing at a time on the stream, and I didn't want to just type this out the correct way to do it or anything because I wanted to show how we sort of loft up into the correct structure. Let's see. A lot of people are asking questions that are more like pre-stream questions. If you want to ask questions like some of these, which are, is C or C++ best if you want to code games, and have you thought about teaching at universities? What are on your hands? Those sorts of things. Any questions that are just not related to the code that we're working on today or in a previous day, come to the pre-stream. Come 15 minutes before the stream starts. I'm usually, before the scheduled time, and I'm usually on and answering questions like that. Is there an advantage using bool 32 instead of bool 8-bit? Yes. I mean, basically, you don't want to be using values that aren't the most convenient value for the processor, and so 8-bit is typically not the most convenient value. It's not aligned to a 32-bit boundary, and there's a bunch of things. I mean, we'll cover this a little bit more later, but basically what you want to do is you want your Boolean values, when you're just throwing them around, you want them to be basically whatever the type is that the processor is most comfortable dealing with, if that makes sense. So when you store them, you might want to pack them into bit fields, which we'll probably do in the future for things. And when you're just computing with them, you typically want them to be just whatever the easiest value is for the processor to deal with, which is usually 32-bit. Can you go over briefly how to encode the tile data in a single uint32? I couldn't get it the first time. Well, we haven't really encoded any tile data yet. I just used a uint32 because I needed some number that would say occupied or not. So I just used a 32-bit value, and all we're doing is storing a 0 and a 1 in there at the moment. So this will get more complicated. Our tile structure will not be a uint32 in the future. It'll be some kind of a struct that has information in it, like what the tiles, what kind of tile it is. Is it earth? Is it water? Is it whatever? And like what its properties are. Is it magical? Does it have health on it? Those sorts of things. Why does left and right side collision work, but not the top and bottom? So the reason is because I don't know if you've ever seen. So here's, if you've ever seen like, oops. If you've ever seen something like a standard tile map game, I'm not sure how to show this well. Okay, so if you've ever seen a standard tile map game, right? They tend to look like they've got like a wall or something like this, and then maybe there's like a rock here or something. So, this sort of thing. And the hero, right, is like this little dude, who's hanging around, and he's got like a sword, right, and all that kind of stuff. When he walks around, he can't walk into an obstacle that's like left or right. He can't interpenetrate them. But when he walks up to something like this rock, he can actually eclipse it quite a bit, right? He can kind of stand right in front of the rock with his sword or whatever, right? And that's because of the sort of fake perspective that games have, where like they're not really top down a lot of times. They're sort of like fake 3/4, where even though like the tiles are square, the guy is drawn as if you're kind of looking at him from the side. So we want to let the collision allow the guy to walk all the way up there. And maybe, you know, maybe we want him to stop a little bit away from it, but just a little bit, not all the way. When it comes down to something, then we do want to stop him there potentially, or maybe we want to let him go a little bit behind it. I'm not sure. But either way, you can kind of see what I'm getting at there. There's like this kind of weird perspective rule. So we don't know exactly how we want to model that in the game, but that's why I'm allowing him to do that. The reason in the code that it works that way, like the reason how the code accomplishes that, is we're checking 3 points for collision. And those 3 points are there, there, and there. We're not checking any points up here. So it stops when this point hits the edge, and it stops when this point hits the edge, right? But it doesn't stop when these points hit anything. Those points can hit anything they want. So it will only stop once one of these points gets up and hits the tile, right, which is right there. Why are you using number 32? I'm not sure what that means. Why save tile width height in each tile map if these values never change? So we probably won't. I guess this is what I was saying before. We had to stop the stream before we lofted stuff out of the tile map and into the world struct. So yeah, sorry, we just didn't get there. What are the differences between structs and classes? There is no difference between a struct and a class. Basically, C++ just uses a different access control depending on which you pick. So basically, struct essentially has no restrictions on who can access its members. So if I have struct foo int x, and I want to access that somewhere, so I'm inside main, and I have one of these, foo.x, that's allowed. I can access x. If it was a class, I would not be able to. This would give an error, right? It would say that you know, only it's a private member. And so really the only difference between them is you can think of if there was some master thing, if there was some Uber guy called like you know, storage or something, then storage foo would be, or I, you know, I don't even need to introduce that. So struct foo, right, is just class foo with a public on it. So struct foo equals class foo with public at the top. That's what struct foo is, and the opposite is true as well. Class foo is the same as struct foo with a private at the top. So that's it. There's no other real difference between them. I mean, the same is true of inheritance. Like if I inherit from something, if I say public bar here, that would be the same as me not saying that, right? I could, and vice versa. Like I could inherit this guy privately here, and I would be equivalent to what would happen. I think. I'm pretty sure that's. I don't use inherit. The last time I used inheritance was like 2001 or something, so I don't remember. But I believe inheritance does the same thing, where it's like the public and private is inverted. Let's see. Not many questions about the code. Do you always have to put int32? Can you use only int? Okay, so I see what the question is about now. So basically, what we've done here is int in C has traditionally been ambiguous. There's no telling how big int is. It could be 8 bits on old computers. It could be 16 bits on more modern ones. It could be 32 bits on today's computers, or in the future, it might even be 64 bits sometimes, right? Who knows where it could go from there. So when you say int, you have no idea how big of a number you can store in C. I don't think. I mean, maybe there's something in the spec that says it has to be at least 8 bits or at least 16 or something. But int in general, I don't think has to be any particular size, if that makes sense. So what we want to do when we're programming most of the time is specify what at least we think the minimum size we need is for things on the platform, right? So I'm using int32 to be, I defined int32 to basically be something that is a 32-bit integer because that's usually what I want. And when I want a 64-bit integer, I'll say int64, et cetera, et cetera. So you can see these typedefs I made up here. So there's nothing wrong with using int. It's just that it's harder to control because you don't have any idea what size that actually is. So that's basically it. Wait, so int32 is because you want to make the game for 32-bit computers and later you'll optimize it for 64-bit computers. No. It is simply because I want to make sure that the values that I'm talking about are 32 bits wide. It doesn't have anything to do with optimization. It has to do with the fact that 16 bits would be too few, if that makes sense. And also the fact that that x86 and x64 tend to be very happy working with 32-bit values, so you tend to want to use those most of the time because they work good on aligned 32-bit boundaries and so on and so forth. So this code that we're running right now is actually being compiled as 64-bit code. But we don't use 64-bit integers because a lot of times they take up more space and we don't actually need the extra 32 bits that they provide. And they also are more expensive to compute with because when you're using like SIMD and stuff, a 32-bit integer you can do 4 wide or 8 wide or 16 wide depending on the width of the SIMD unit, whereas 64-bit you get half that. So yeah, so no, we're already compiling 64-bit and optimizing for 64-bit basically when we actually start doing optimizations. But we're saying that we want to store 32-bit values in places. The player moves faster diagonally than it is supposed to. Are you planning on fixing that? Well, did you look at the code before asking that question? I don't think that you did. Because if you notice, it says right here, to do Casey, diagonal will be faster, fix once we have vectors. Did you notice that? Why did you not look at that? Maybe you were just going by the video and you don't have access to source code, and that's fine. But we have a comment for that. How do you plan on handling code duplication in enemies or other game entities without inheritance? Well, we'll have to see when we get there. Looks like there are no more questions about today's code or previous code, so I think we're basically done. I'm not familiar with pound define. What is it used for? Well, pound define is just a macro. So all pound define does is pound define says anywhere that you see this string, replace it with this string. It's just a straight substitution in text form. So instead of like a constant that actually has a type, like for example, if you say, you know, int const foo equals 4 or whatever, that means that this is actually an integer type that gets inserted in your code and you couldn't use it for something else, right? Whereas pound defining it is literally text. So you could even, you know, use it to do something where that had nothing to do with whatever its actual value was, and that just had to do with the text of the thing, right? And so sometimes you use them to you know, just replace. I don't like typing the word static, for example. So I like to define the word static, which has multiple meanings in C++. I don't like the fact that they had multiple meanings. So I make 3 different keywords basically using define that are textual substitutions so I can use the one that I want for the situation that I want. And I think it's clearer to read that way. When you use int32, does it have a different influence on the code than normal int? No, not on this platform because int32 and int are the same on this platform. On other platforms, it might, because if int was defined to be 64 bits on some platform, then int32 would have a different effect because it would be 32 bits instead of 64 bits. All right, so I think that's it for today. What I would like to do is I'm going to go a few minutes extra on the stream here because on the in the forums, someone was requesting an edit to the H file that I am totally fine with making. And so I want to go ahead and make it, but I didn't want to take up stream time for it. So I'm going to go ahead and do it. Basically, what they were wondering is, could we make the header file clean for being basically C, could we make it clean so that in C++ it would just compile? And I'm sorry, that it would compile clean in C. So even if you didn't have C++ and you were trying to write a platform layer with something that couldn't compile C++ code, that you could use it. And I think that should be pretty easy actually to do. So I'm going to go ahead and try that. Basically, what I want to do is split out Handmade, this thing here, split it out into essentially a Handmade .h and a Handmade platform .h. So Handmade platform.h will have just the bare minimum that would be necessary. And so I'm going to go ahead and see if I can do that. So if I do this, let's see here. I want these guys. I don't need pi though. I need these in there. Well, do I even need those? Let me see what we pass. I'm just trying to figure out what we need for the platform layer to talk to us. Yeah, we do need those. So we need those. We don't need any of this stuff. So we're just going to pound include Handmade platform right here. Yeah. So we got to pound include those. What else have we got? We don't need any of that. We need these. So we need this stuff. We don't need get controller. That can stay outside. So we need game input, right? We need these guys. We need, let's see, all of this. Yeah, we need all of this stuff. Needs to come up. So let's put that in there. And we need, I think that's it. That's all we need. Pretty sure. Yeah. So basically what I've done is I pulled out the bare minimum that you would need to call us from a platform layer. And now what I'm going to do is I'm going to make this compile in C, right? And so what I want to do is eliminate anything that is C++ in it. So first of all, I need to make sure that we always type def. So in C++, it always will define, if you have like struct thread context, you can then use the word thread context, right, as a type name. In C, that wasn't true. You had to actually also type def these like that. You had to type def them so that to actually get the name to be used as a type. So we need to do that everywhere that we have one of these sort of structs that the platform layer talks to, right? If that makes sense. So that's pretty straightforward to do. Type def like this. Type def that. There we go. To type def this game button state and that. So I'm really just going through and doing some basic stuff here. I don't know how C will fare with this thing. I'm a little worried about it. We could at this point go ahead and pull it, but we'll see. We'll see what happens on the C compiler here. So I'm going to go ahead and finish type defing all these guys. And I think that may just be all we really need to do. Not sure there's really anything else to do. Yeah. Looks pretty sane to me. We can also extern C this. So there's an if C++ extern C thing that we can do. I don't know if that will help people. Let me go ahead and close this down so we can compile. So there's a way you can do basically an if def for C++. If def C++ extern C. I forget what the thing is for it. It's this thing. It's this thing right here. This is what we want. So essentially, all we're trying to do here is say, all right, basically everything in this file, if we're compiling with a C++ compiler, let's treat everything in this file as if it was C code. So let's see here, close that out. So only if we're on the C compiler we'll do that. And that just makes it so these names don't get mangled. I don't know if you remember, we did some stuff with this inside handmade.cpp. We did this extra in C thing, right? And so that basically says apply that to everything that we've got. Make sure all of these names don't get mangled. I think this will be a slightly better, like I said, I did the minimal stuff, but I think this will be all you would need now to be able to build a platform layer link to Handmade Hero. And then now we've got all our sort of other stuff that was kind of in the platform file that doesn't have anything to do with calling us from the platform layer. We've sort of put that in here. Now I suspect math.h is probably not necessary. Am I correct about that? Let's see here. In fact, I don't even know if we use math.h anymore, do we? Yeah, we don't. So that was only for our sine wave, so maybe we'll get rid of that and we'll go, when we want to do our sine wave again, we'll implement sine ourselves, like it said. Standard int is there. We could decide to get rid of standard int as well and just define these to be something right now because we know what they are, and later put our own sort of crackers in here. So for example, what that would look like is we would go ahead and say, all right, there's no standard int anymore. We're going to say that int 8 is a char, int 16 is a short, int 32 is an int, and then, this is, well, you know what? I guess I can't even do that now that I think about it, because I don't know if there's a standard platform type for N64, because it's like long, or it's underscore N64. I don't know if there's differences there. So maybe we'll leave that in for now. But one thing we could do is go look to see if there was I don't know if there's a standard way we can write 64 here now. And if there was, we could go ahead and do that. We could go ahead and do that as well, and that would get rid of this pound include, which might be helpful. Now, I don't know, do we actually use any of the pound defines in here either? We might not. So another thing we could do, we can get rid of these guys, right? So we could get rid of our pound defines and move them in there. Yeah, so that's another thing we can get rid of. So we're just going again for the minimal stuff that we need in here that gets passed between the two layers. And it looks like that is probably as minimal as we're going to get for now. I think that's good. Now, again, we could get rid of that thing. Let's see. Is there a platform? Is there a C standard for 64-bit integer? Oops, that was a good spelling there. Integer. And so let's see. Do we have anything? No, we don't want to. We don't want to include that though. That's the thing. Is there just a standard without having to include standard int? Because I don't think, yeah, there's nothing you can do. We don't want that. So I don't know if there's a way to do that. The way that you used to do this sort of thing is, the way I would do it is I'd do like a pound if, and then in the pound if, you would put whatever the compiler name was or the platform name was that you were working with, and if so, you would use their particular way of defining that in 64. So I don't know. We could look at doing that in the future, but for now I think that's it because I want to wrap up the stream and not go too long. But there's a good start for people who wanted those things separated, and so you could take a look at that. So like for the person who requested it, for example, was the person who was doing the Swift port. Take a look at that. See if there's anything else that you need to be done there, but that should give you a better start, sort of out. And you know what? I'll move this guy out here as well. All right, so that should do it. I think that should do it. And then we'll wrap that for today. So everyone, thank you very much for joining me. I hope to see you back here again at 10 a.m. tomorrow. We'll be doing this again, and we will go ahead and see if we can get our guy walking around to multiple tile maps tomorrow, which will put us in good shape for actually starting to construct our world, which I am interested in doing. So I think that should be fun. Thank you very much for joining me. If you would like to purchase a copy of Handmade Hero with the full source, you can do so. The pre-order button here will give you a download link so you can download the source code to the game if you'd like to play around with it and follow along every day when we do coding. you will be able to download the source every night as soon as I update it. If you want to support the video series, we have a Patreon you can subscribe to. And of course, we also have a news and forum site you can go to, which has tons of useful information. It's got the schedule here. It's got an episode guide where you can catch up on old episodes. It's got a coding resources page where people have ports to Mac OS X, Linux, and so on. We've got a code discussion forum where you can post your questions. So we basically have everything up there that you would need to follow along with Handmade Hero. So I encourage you to check that out. Thank you so much for joining me here. I hope you have a very Merry Christmas if you are celebrating Christmas today. And I will hope to see you tomorrow at 10 a.m. sharp Pacific Standard Time. Thanks, everyone, and we will see you tomorrow.